So I've got a health food business in honor of one of my first hour students. They would like to create a high potassium blend of dried fruit in the form of a box of fruit bars. Decided to use apricots, which have 250 milligrams of potassium per serving, and dried dates, which have 200 milligrams of potassium per serving. I did have to fudge those numbers. Like those aren't the actual numbers because like apricots have like 407 milligrams of potassium, and it just was going to make things ugly if we use that number. So those aren't true numbers there, but still a good idea. The company can purchase fruit in bulk for a reasonable price. Dried apricots cost about $9.99 per pound for 3 servings. Dried dates cost $7.99 per pound for about 4 servings. The company would like the box of bars to have at least the recommended daily potassium intake of about 4,000 milligrams. I'd like to keep it under the twice recommended daily intake. In order to minimize cost, how many servings of each dried fruit should go into the bars? So we need to start by defining our variables. What is it that we don't know, but we do have control over? What is it that we don't know, but we do have control over? That's what your variables should be. Okay, servings of dates, servings of apricots. Okay, so it says there, right? How many servings? It shouldn't be a big mystery, guys, what you're trying to find. It should ask you, okay? And part of one of the last sentences should say something like, here's what we're trying to figure out, right? How many servings of dates and how many servings of apricots. So again, you guys get to pick which letters you use here. I really would recommend you use X and Y because you're graphing. You get to pick which order you put them in. Again, I would recommend you start with the first one that they say. So in that case, it would be apricots, and then it says dates later. But what you don't get to pick is that it's what they're asking about, the number of servings. Right? Those need that phrase. How many servings? That phrase needs to be part of your variables. The number of servings of apricots, the number of servings of dates. Okay. So we've got our step 1, define the variables. And then we go to step 2, that objective function. What's the overall objective of this company? What do they want to do? Lucas, what do they want to do? Mm-hmm. So what's the objective? So that means we need to start thinking about costs. What does it tell us about costs? Okay. So how would I use that? Yeah. So Lucas is saying 999x plus 799y would be our cost function. There's one little issue with that. Okay. Our x stands for the number of servings of apricots, but it says that the 999 pound would give us 3 servings. What do we have to do with those costs they're giving us? Oh. So yeah, on that 999, we would have to divide that by 3 to figure out how much 1 serving would cost us. Whereas 999 divided by 3 would be 333. So what we need here is a unit cost, right? How much is 1 serving cost us? Not how much does 1 pound cost us, because a pound is in the serving. Okay? So this part's a little bit tricky with this problem. This might want to make sure I wanted to do it with you guys in class because this can mess you up. So 1 serving of apricots costs you $3.33. Okay? And then the dates with the $7.99 divided by 4, that's so close to 2 that it's essentially 2. It's 1.9975. So we had to watch out for that. There's a little trick there with this one. You guys won't run into that on your own when we're asking you guys to do something. And we want to make sure that we talked about that one together. Okay. So there's our cost function. We'll come back to, all right, you write that, set it to the side, come back to that later at the end of the problem. Now we need our constraints. Why don't they just have zero costs, right? Want to minimize costs? Well, that'd be zero costs. What are they trying to do that's forcing them to spend money? Where's the constraints here? I can hear you, Ella, sorry. Okay, so they want to create something with a certain amount of potassium, right? They want to reach this 4,000 milligrams. So how are they doing that, Ella? $250x because the apricots have 250 milligrams. Okay. Because the dates have 200 milligrams. Okay. Not equals, but it says it wants to have at least. Greater than or equal to, right? You know, a number that's at least 4,000 would be 4,001. A number that's at least 4,000 would be 5,000. A number that's at least 4,000 would be 7,000. So what this adds up to needs to be more than 4,000. So again, that we say at least, but we end up using a greater than. We got to watch out for that. Any other constraints here? That's 10 bars. Nothing we have tells us anything about bars, so we don't know that. They must have something else. It's not just like a date or apricot bar. So there's a lot of information there we don't have regarding the bars. So do they want like 4 million milligrams of potassium in the bars? No. They say they also want to keep it under twice, right? You guys ever heard that saying that Americans have the most expensive pee in the world? We take all these vitamins and stuff. Like your body can only handle getting so many vitamins in it. And if you take 300% of your potassium for the day, your body's like, I don't want that stuff. So kind of goes. Okay? If you take like a vitamin C pill, it gives you like 7,000% of your vitamin C for the day. Your body doesn't need that. So it just pees it out. We're spending all this money taking stuff in our body that our body can't use, so it just goes down the toilet. There's no point in having a huge amount of vitamins in this, so they're saying, well, we need to limit it also. Yeah? So there's also an upper limit. So twice the recommended daily intake, so that's going to be what? 8,000? What about over here? Yeah. The apricots and the dates haven't changed. They only have some, that hasn't changed, so what we're changing is the limit, not changing what's in the apricots. Still talking about how much potassium is in them, right? But now that's the upper limit. So what's that mean about our symbol? Flip it around. And we need it less than that. Okay. So there's our objective function. There's our constraints, right? It doesn't say anything else about like potassium, right? There's nothing else about servings. Yeah? So there's all our constraints. So obviously we need to get those into slope-intercept form so we can graph them. Is there anything you guys want to talk about before we move on to that next step? Like, I mean, this is really where everything else we do now is just doing. Right? We're done thinking essentially. We just need a bunch of doing. So, but the thinking is going to be the hard part. So something you guys need help clarifying where something came from, why we did this, how you're going to do this on your own. So let's get those into slope-intercept form. I'm going to kick the 250x over for the green one. And then divide by 200, so that would give me y is greater than or equal to 250 divided by 200. You put that in a calculator, you're going to get a decimal out of it. Right? They both have 50s in them. There's 5 50s in 250, and there's 4 50s in 200. You want a fraction. You don't want a decimal. We need it to be a slope. And 4,000 divided by 200 is 20. And with the other one, when you kick the 250 over, so you get 200y is less than or equal to negative 250x plus 8,000. Same thing is going to happen with the 250 and the 200. I'm still going to get negative 5/4 x, but then now 8,000 divided by 200 is 40. So there's the two lines I need to draw. First thing I always go to look at when I think about, okay, well, next thing I need to worry about is my scale. What am I going to count by over here? And on the x-axis, so I look at that y-intercept and say, well, what's my y-intercept? That should give me a decent idea of where I need to count to. So I see 20 and 40. So I need to be able to get to at least 40 on my graph. Sometimes we have to worry about if the graph has a fairly low slope, that the graph can be kind of long compared to how high it is. This graph actually has a pretty steep slope. It drops more than it runs. So just from having done this a billion times, I know that this x-intercept is going to be less than 40 because it's dropping faster than it's running. So I know there was a problem you guys had on your homework where it ran pretty far in the end because it had a small slope. So I need to be able to get to at least 40 on the axes. If we count by, these have, again, 20 boxes. Again, generally it's not a great idea to put this number right at the top. So if I could go to 50 or something like that, then I could see what I need to see. So if we use every 4 boxes as being 10, that should get us to 50. And I'm changing the scale, so I have to make sure I label that. Again, it's always a good idea to label, even if you aren't changing the scale, just a little bit. But if you change the scale where it's not counting by ones, you have to label it. So I'm using every 4 boxes as being 10. I'm being consistent. That's the thing too, when you make a scale, you have to make sure you're being consistent. 4 boxes is 10, 4 boxes is 10, 4 boxes is 10, 4 boxes is 10. I can choose the scale, but it has to be consistent. It can't go like this one's 10 and then there's 50 and this one's 100. Like that's not consistent. It went up by 10, then it went up by 40, then it went up by 50. That's not consistent. Okay? That's not okay to do. So the first one starts at 20, goes down 5, right 4. It's kind of hard to do here. Be down 3. Boy. What did I do last time? I had a much better scale last time. Did I count by 2s? This is the first hour, and I had a much nicer graph. Because I can't go down 5 anymore, that's not good. Because then going over something's difficult. I'm not happy with what I did. That's not good. I don't know. Not easy. I'm not able to count that out easily, so I'll try something different. Sorry about that, guys. Let's see. What else can we do? Yeah. I guess since I know, again, I only know this because I've done problems like this a whole bunch of times, and I've done this problem particularly before. I know my x-intercept isn't going to be more than 40, so I'm kind of cheating here on this side of things, like how to scale things. And there's no like exact way to do this. Like I tried something and it wasn't working, so I'm trying something different here. It's more of an art on this side of things, like figuring out what to scale by, because you don't want the graph to be tiny. You don't want the graph to be like filling everything usually. You want to kind of take up most of the space, but not all the space. So to go from 20 down 5 over 4, down 5 over 4. That's only 3. Should get you to that point there, which should be 16. Here, look at that, not be 16, is that what you're saying? Be 2, 4, 6, 8, 10, 4, 12, 14, 16.
You go right 4.
Right 4? Yes. Down 5, right 4. Down 5, right 4.
So if it's down 5,
Yes. So what I'm, skipping over a little bit. So if I go from down 5, right, which would be where 15 is, right, then I'd be going over 4, which would be right there. Then I go down another 5, I go right there. So really I went down 10, right 8. But I was counting down 5 boxes, right 4 boxes, because the boxes are the same size. So there's something you have to really watch out for. If you do ever make the scale different on the y and the x-axis, you really have to be very careful about how you do your slope. So it's not a good idea to have different scales here and here. It's okay. It is something you can see, but it's really not a great idea for where you guys are at to do different scales here. You got to be really careful about your slope when you do that. Because the scale is the same on both, I can still go down 5 boxes, right 4 boxes. It gets me to the same place. Because I'd just be going down 10, right 8. Down 10, right 8. Which is just, 2 of these. So yeah, sorry for that confusion there. Kind of glossed over something. So the other one start up at 40. So down 5, right 4 again. I'm going to do the same little trick. I'm going to go down 10, right 8. So it doesn't take so long. But this should get us to 32. So from 40 to 32. Oh, we did talk about that yesterday, that idea that there are the implied limits as well, like that we can't have negative servings of things. So it's not a big deal if you guys don't do these. They are just implied. But you can't have negative servings of either thing. In these real life problems, you can't go below the zeros. So it's not a big deal if you don't put those there. Okay. So we did talk about that real briefly yesterday. So, but this one is, y is greater than, so that means we're shading above the green line. And the other one is y is less than, so it means we're shading below the red line. So we can see that space between the lines there is where our answers are. And to the right of the y-axis, above the x-axis because of those implied ones. So anywhere in here would be answers. That any point in this space would answer the question. But if we're trying to maximize or minimize, we need to look at those vertices. one of those points would be the maximum, or one of those points would be the minimum. And we're after a minimum in this one because we want to minimize costs. So those are the 4 points you would test. See which one actually minimizes the cost. So I have 0, 40 up there, I have 0, 20, I have 16, 0, and 32, 0. So those are the locations of the vertices. You're going to plug them back into your cost function up here. So 333 times 0 plus 2 times 40, 333 times 0 plus 2 times 20. That one better be less than the one above it. Let's see, this is 333 times 16 plus 2 times 0. 333 times 32. That seems kind of silly to do this one. There's no way it could be cheaper than the other one. 2 times 0. There's no way this top and bottom one could be right as far as being cheaper. So 2 times 20 is 40. What's 333 times 16? About 40. 3 times 16 is 48. So yeah, it's definitely more than 40. What is it? What'd you get, Lucas? What's this answer? There's our minimum. We're minimizing costs, right? Yep, so make sure you pay attention to that, right? We want to minimize costs, right? Minimizing costs. So what's that mean, right? What did 0 stand, or what did the X stand for us? Yeah, servings of apricots, and servings of dates. So looks like no servings of apricots and 20 servings of dates would be the minimum costs and meet the requirements. Is it apricots? Is it apricots? Does it matter? So there's the full problem, right? There's a lot of stuff there that we have to do. But again, I think after this point here, you're just in the doing phase. Like this is all you're thinking here. The rest is just doing. So I like to at least set up the next problem. You don't necessarily have to do all of it. But I want to get through the variables and the constraints and the function. Anything feeling weird? Anything you're not sure about? So we've got a company. Oh, this problem is very dated. MP3 players and DVD players. Do you guys know what those are? Okay. MP3 player gives a profit of $30, while DVD player gives a profit of $70. Company must manufacture at least 10 MP3 players per day to satisfy an order, a customer, but no more than 50 because of production restrictions. They may just not have enough materials. They may not have, the machine may only be able to make 50 in the time that they have. Like, who knows what the restriction is, but they can only make no more than 50. The number of DVD players cannot exceed 60 per day. So maybe they get kind of some sort of either supply or machine restriction on how many can be made. How many of each the company manufactured to attain maximum profit? So what are the variables? What don't we know, but that we do have control over? Connor, what are you saying? What don't we know, but something that we do have control over?
Number of DVD.
Okay. And what else? Okay. right? How many of each, right? So I probably would have them switch just because it says MP3 first and DVD second, but in the end, it doesn't matter. Okay, so it'll give us the same answer at the very end. Our graphs would look slightly different, our equations will look slightly different, but the answers will all be the same. So, okay, so there's our variables. Again, I'm expecting you guys to not just say DVD players, not just say MP3 players, but what is it about them you're trying to find? And it should always ask you pretty point blank. And you can say how many DVD players, you can say how many MP3 players. I like to say number of, just it's less writing. Okay. All right, so what's our objective function? Natalie? What's our objective function? What are we after here? What does this company want to do? Okay, so I want to maximize their profit. So what do we know about that profit, Natalie? I'm going to call the equation P just for profit. Okay, so what are you going to do with that 30 times by, yeah, so y in this case, since it was 30, the 30y. And then what about the other one you said? Okay, 70 times x. There's certainly nothing wrong with writing it with 30y plus 70x, because we're not trying to graph that, right? So no, it doesn't need to be in. If you want to write it the other way, you can. 70x plus 30y. Okay, thanks, Natalie. So what's a restriction here? What's a constraint? Why don't they just make a billion MP3 players and make all sorts of money? Jake? It's something that's limiting things. We need to talk about our constraints. Like what are the limits on them? Why don't they just make all sorts of stuff and make all sorts of money then?
They can only make their maximums.
50 what? Okay. So what's MP3 players to us? Which one did we define as MP3 players?
Oh.
Okay. So we're saying y has to be no more than 50. So we're comparing y to 50. How would you compare y to 50? Y is no more than 50. Y is less than or equal to 50. Okay. They can make 40. They can make 20. They can make 27. They can't make 60. Okay. What else is constraining them? Okay, so we can't do more than 60 DVD players. So what's DVD players to us, Jake? X, and then we have to compare that to 60. Less than or equal to 60, cannot exceed 60. Okay. Can't be more than 60, could be less though. Okay. One other thing. Okay, Jacob? Yep. So they have to make at least 10. So we need to compare, or it's y, isn't it? So how would y compare to 10? Yeah. So those y lines, remember, those are horizontal. So you'd end up with these two horizontal lines, and that x line is vertical. And you get your shading, but you're going to end up with this space, right? And you're just going to look for those corners. Okay. So try those 3 problems that you got today. Hopefully they make sense, right?